Hi. In my last couple of videos, I talked to you about conditionals. That is, logical statements that say that if one thing is true, then another thing is true. In this video, I'm going to talk some more about issues related to conditional statements and about ways that you can switch things around. So, reminder. A conditional statement says that if one thing is true, then another thing is true. And for the entire conditional statement to be considered true, the antecedent, the if part, could be either true or false. The consequent, the then part, could be true or false. But you can't have the if part being true and the then part being false. Then the whole thing would be a false statement. So in the example we're looking at here, if you live in Illinois, then you live in the United States, it might be true that you live in Illinois and that you live in the United States. It might be false that you live in Illinois, but still true that you live in the United States. Or it might be false that you live in Illinois and false that you live in the United States. But it cannot be true that you live in Illinois while being false that you live in the United States. Now, suppose we interchange the antecedent and the consequent. Instead of P implies Q, we say Q implies P. So in this example, that means instead of saying, if you live in Illinois, then you live in the United States, we say, if you live in the United States, then you live in Illinois. So this is what's called the converse of the original statement. The converse of a conditional statement is what you get when you interchange the antecedent and the consequent, the if and the then part. But the converse of a true statement is not necessarily true. It's not necessarily true that if you live in the United States, you live in Illinois. It's possible that you could live in the United States, that part is true, but that you live in Illinois would be false. Say, for example, if you live in Texas. If you look at the truth table, comparing the truth values for the original conditional, P implies Q, versus the converse, Q implies P, you see that they do not have the same truth values. They are not equivalent. So be careful. The converse of a true statement is not necessarily true. It's not logically equivalent to the original conditional statement that it's the converse of. Another way we could switch things around would be to leave the antecedent and the consequent in the same place, but negate both of them. That is, go from P implies Q to not P implies not Q. In this example, that would be changing if you live in Illinois, then you live in the United States to if you do not live in Illinois, then you do not live in the United States. And that would be what we call the inverse of the original statement. So the inverse of a statement is where you have the negation of the antecedent implying the negation of the consequent. Just like with the converse, the inverse of a true statement is not necessarily true. It's possible for you to not live in Illinois, but still live in the United States. That is, it's possible that you do not live in Illinois could be true, but you do not live in the United States could be false. So if you look at a truth table, you will notice that the truth values of the inverse are the same as the truth values for the converse. So the inverse and the converse are logically equivalent to each other, but neither one of them is logically equivalent to the original statement that you started out with. One more thing we could do to a conditional statement would be to switch around, that is, interchange the antecedent and the consequent, and at the same time negate both of them. That is, go from P implies Q to not Q implies not P. So in this example, and that would be called the contrapositive. So in this example, the contrapositive of if you live in Illinois, then you live in the United States would be if you do not live in the United States, then you do not live in Illinois. And that is a true statement. That is logically equivalent to the conditional statement that we started with. If it's true that if you live in Illinois, then you live in the United States, it must also be true that if you do not live in the United States, then you do not live in Illinois. So to summarize, for a conditional statement, P implies Q, or if P then Q, the converse of that statement would be Q implies P. If Q, then P. You just interchange the antecedent and the consequent. The inverse is not P implies not Q, or if not P, then not Q. Leave the antecedent and the consequent in the same places, but negate both of them. And the contrapositive would be not Q implies not P. If not Q, then not P. So you both interchange and negate. The contrapositive is logically equivalent to the original, but the converse and the inverse are not. And if it helps you to visualize why this is true, if you're a visual thinker, you could think the original statement is like saying, if you're inside the small circle here, you must be inside the big circle here. The contrapositive of that would be saying, if you're not inside the big circle, if you're outside the big circle, you must be outside the small circle. So inside the small means inside the big, outside the big means outside the small. So let's practice on a couple more examples. Take the original statement, if you're a monkey, then you like bananas. What's the converse? If you like bananas, then you're a monkey. What's the inverse? If you're not a monkey, then you don't like bananas. What's the contrapositive? If you don't like bananas, then you're not a monkey. And which one of those is equivalent to the original statement? Which one of those is true if the original statement is true? The contrapositive. So if you believe that if you're a monkey, then you like bananas, it's not necessarily true that if you like bananas, then you're a monkey. It's not necessarily true that if you're not a monkey, then you don't like bananas. But it must be true that if you don't like bananas, then you're not a monkey. Let's try another example. If a number ends in 0, it is even. A number that ends in 0 must be an even number. The converse, if a number is even, it ends in 0. The inverse, if a number does not end in 0, it is not even. The contrapositive, if a number is not even, it does not end in 0. And which of those is actually a true statement? The contrapositive. The converse isn't true. A number can be even without ending in 0. The inverse is not true. A number that doesn't end in 0 might still be even. But the contrapositive is true. If a number is not even, If it's an odd number, then you know for sure it can't end in 0, because if it did end in 0, it would be even. Now, so far we've been looking at conditionals, going one particular way. It matters which is the if and which is the then. But a related kind of logical statement would be the biconditional, that one thing is true if and only if a second thing is true. P, if and only if Q. That's symbolized with this kind of an arrow that points both ways. So that means that for P to be true, Q must be true, and that's the only way that P could be true. So another way to put it is that P and Q have the same truth value as each other. They're either both true or both false. So if either one of them is true, the other must be true. If either one of them is false, the other must be false. It also means that if P is true, then Q is true, and at the same time, if Q is true, then P is true. And another way to put it is that if P is true, then Q is true, and that's the only way that Q is true. So if P is not true, then Q must not be true. So an example of a statement like this would be, a number is divisible by 10 if and only if it ends in 0. So there it does go both ways. If a number is divisible by 10, you know from that fact that it must end in a 0. And if a number ends in a 0, you know from that it must be divisible by 10.